Yes, hello. Today we're going to be looking at the first part of finding an equation for a sinusoid given its graph. In particular, we are going to be looking for the midline equation, the period, the frequency, the amplitude, and the phase shift of a sinusoidal graph. We will then use these in a subsequent video to define parameters a, b, c, and d from the general sinusoidal function. And from there we will be able to construct our equation. So without further ado, let us begin. We begin our little journey here by reviewing some of the parent function properties of sinusoidal functions, in particular as they pertain to y equals sine of x, because any sinusoid is a transformation on this function. I strongly recommend pausing the video at this point and taking down all of the information that you see here. We start by looking for our midline equation. This is the line that cuts our sinusoid in half. If you will, it is the line segment where the maximum points are an equal distance above as the minimum points are below. For us, this line is going to be defined as y equals -2. Very simple. Finding the period of a sinusoid is not as simple as just looking at the graph. A little bit of arithmetic may or may not be necessary. Generally speaking, what we do is we try to find the distance from one maximum to the next. Thankfully, we won't need the distance formula to find the distance between these 2 points. Simply subtracting our x's will be more than enough. The period in this case is going to equal 3 pi over 2 minus the other x, -pi over 2. And of course, subtracting a negative is the same as adding, so we get 3 pi over 2 plus pi over 2, which gives us 2 pi. As for the frequency, remember it is the reciprocal of period, so for us, our frequency is going to be 1 over 2 pi. Amplitude is defined as the distance from the midline to one of the peaks. If we look very closely at our graph, we'll see that the midline is at -2 and our peak is at -1 2/3. This distance right here is our amplitude, and the distance, of course, from -2 to -1 2/3 is equal to 1/3. That is our amplitude. Finally, finding the phase shift will be perhaps the most difficult because it requires the most background knowledge. In particular, we need this information right here, specifically that sine goes through the origin and then up to a maximum. So to find the phase shift, we need to find the first interval after the origin, where sine goes through the midline and up to a maximum. That's this one right here. Next, we will see how far that midline value is away from the y-axis. This distance is equal to our phase shift. In our case, this distance is pi units away from the y-axis, so the phase shift is equal to pi. And that is it for now. The midline is the line that cuts through the center of the sinusoid. The period is going to equal the distance from subsequent peaks. The frequency is going to equal the reciprocal of the period. The amplitude is the distance from the midline to a max or a min. And the phase shift is the distance from the first midline value that goes up to a maximum after the y-axis to the y-axis. It is very important that you are able to correctly find each of these characteristics. We will be using them quite a bit when we are trying to define the equation for the graph shown above in the subsequent video. As such, if you are unsure about any of these characteristics, I encourage you to watch this video again. When you are ready, I will see you in the next video. So thank you very much for coming, and I will see you next time.